Students, today I am here with a new video, the short questions of chapter 11, which is heat and thermodynamics. So without wasting our time, let's start. Why is the average velocity of molecules in a gas zero but the average of the square? According to kinetic molecular theory of gases, average number of molecules moving in a certain direction with a certain velocity are equal and opposite to the number of molecules moving in opposite direction at certain velocity. So that is why average of their velocities is equal to 0, which can be given as. But we know that square of the negative quantity is positive, hence the square of the velocities is not equal to 0, and it can also be given as. Why does the pressure of a gas in a car tire increase when it is driven through some distance? Work done against the frictional forces between the tire of a moving car and the road is converted into heat. Gas molecules inside the tire absorb that heat and their kinetic energy increases. We know that pressure is directly proportional to kinetic energy, hence pressure of the gas molecules inside the car tire increases. Specific heat of a gas at constant pressure is greater than specific heat at constant volume. Why? When a gas is heated at constant pressure, absorbed heat increases the internal energy of the system and also some external work is done. And when gas is heated at constant volume, the absorbed heat just increases the internal energy of the system. That is why specific heat at constant pressure is greater than the specific heat at constant volume. Give an example of process in which no heat is transferred to or from the system but the temperature of the system changes. In adiabatic process, temperature of the system changes without transfer of heat from or to the system. In adiabatic compression, temperature of the system increases, and in adiabatic expansion, temperature of the system decreases. Is it possible to convert internal energy into mechanical energy? Explain with an example. Yes, it is possible. In adiabatic expansion, internal energy of the system converts into work done. It can be given as. In petrol engine, hot gases expand and some work is done by the internal energy. In other words, internal energy converts into mechanical energy. Is it possible to construct a heat engine that will not expel heat into the atmosphere? No, it is not possible, because if it is possible, it will be the violation of second law of thermodynamics. So it is not possible. A thermos flask containing milk as a system is shaken rapidly. Does the temperature of milk rise? Yes, the temperature of the milk will increase. As we shake the thermos flask rapidly, kinetic energy of the milk molecules increases. Since temperature is directly proportional to kinetic energy, hence the temperature of milk will rise. What happens to the temperature of the room when an air conditioner is left running on table in the middle of the room? Temperature of the room increases. As the heat absorbed from the room is expelled in the same room, also the work done by the compressor converts into heat, and this heat is expelled in the same room. That is why the temperature of the room increases. Can the mechanical energy be converted completely into heat energy? If so, give an example. And yes, in adiabatic compression, mechanical energy is completely converted into heat energy. For example, when we rub our hand, the mechanical energy is completely converted into heat energy. Does entropy of a system increases or decreases due to friction? Entropy of a system increases due to friction. Work done against the friction converted into heat, and this heat lost in surrounding and becomes useless. Hence, entropy of the system increases. Give an example of a natural process that involves an increases in entropy. When ice melts by absorbing the heat from its surrounding, then change in heat is positive, hence entropy of the system increases. So hopefully students, you have understood all the questions, and if you like my video, then watch it, share it, and subscribe my YouTube channel. We will upload next video soon.